Hi, this is Jeremy, and welcome to our audio version of our popular blog post, Historians versus Open Source Databases. Which is better? This article is also available in the original form as blog post, but also on YouTube and Spotify. We will link to those in the description. Let's get started. OSIsoft PI, Canary, InfluxDB, TimescaleDB and Ignition. The number of tools you can use to store your data from your machinery are endless. This article provides an overview over historians and open source time series databases. In the current age of industrial IoT, historians like OSIsoft PI or Canary sometimes seem dusty and expensive, especially when compared to modern time series databases like InfluxDB, TimescaleDB, or the cloud equivalents of AWS and Azure. Especially for people coming from IT backgrounds, the benefits of a data historian compared to the scalability of modern databases are hard to grasp. Nonetheless, many companies continue to rely on historians, often in combination with modern IT databases. So there must be something to this. We've also noticed an interesting trend among some of our customers. OT engineers in particular seem to be using InfluxDB. If you're familiar with our last database article, you know that we're a staunch advocate of TimescaleDB over InfluxDB, because TimescaleDB is much more boring, scalable, and reliable, and already includes the very likely needed SQL database anyway. We went down the rabbit hole, analyzed the situation, and came to the following conclusion. Using a historian is less about the performant and scalable data storage and more about the interaction with the data. Here, the difference between a historian/InfluxDB and TimescaleDB is significant. This is also the reason why both systems typically exist side by side. Whilst the modern IT database serves IT people, the historian suits the OT crowd. Traditional IT databases discourage OT people from working with the data. Let's take a look at the typical workflow of an OT engineer working with a United Manufacturing Hub. Background. Let's imagine you are an engineer in operational technology. You can do some programming and might have already executed a couple of SQL statements to work with databases. Your background lies within the areas of industrial electronics or PLC programming. You are mainly responsible for maintaining the existing equipment and help with the integration of new machines, production assets, and systems that correlate with the daily doing on the shop floor. So, what did you do so far? You're now responsible for connecting machines and setting up a UNS, a unified namespace. You were able to quickly install the United Manufacturing Hub, and you used Node-RED to extract data from a Siemens PLC. And you used Sensor Connect to retrofit additional IO-Link sensors. You see the real-time data in MQTT Explorer and COWL for Apache Kafka. You already built a little OE dashboard containing shop floor losses like availability, performance, or quality losses. So, what's your problem? You want to see your data, but where is it? Yeah, you could select it in Grafana, but this is not convenient. You want to work with it, such as comparing multiple process values, downsampling them, calculating the mean, backfilling historical missing data, etc. The intuitive and suboptimal solution, providing direct access to the database. What we as United Manufacturing Hub tried first was giving the OT engineer access to the database behind it by allowing them to use Grafana to build the SQL queries. Using TimescaleDB's functions, it allows calculating the max, minimum, average, etc., group them and combine them with other data streams. For an IT professional, interacting with TimescaleDB is very simple. However, for someone who has hardly worked with relational databases, it is quite complex. This becomes even more tricky when you're set between two machines and just want to see some historical temperature values to better understand the last breakdown. If on top of this, the database doesn't even have user interface, you have to resort to tools like pgadmin. This is a pain and poses additional challenges because such tools require some knowledge of relational databases and their best practices, such as database normalization. But what about Grafana? Let's take a look at the PostgreSQL data source for Grafana. If you just load it in, the graph will mumble together in a green value. Getting some historical data to understand the last breakdown is quite difficult. With the help of way too many clicks, including finding the correct primary key for the asset, setting the time step as the time column, and value name as metric column, one finally manages to create the dashboard. At the United Manufacturing Hub, we are quite accustomed to Grafana. I am one of the main developers here, and despite this, it took me about 45 seconds to get this view after opening Grafana. Things didn't go much better for my colleague Alex. Quite the opposite, even with a step-by-step guide, it took him a few minutes to replicate it. No OT engineer is going to do that while sitting in the dirt between two machines and getting yelled at by some managers because the machine isn't running. We looked over the shoulders of many of our customers and saw that most of them were running InfluxDB or an Historian in parallel, not to build any industrial IoT application, but just to see their own data. Let's get to the topic of historians. An OT engineer just wants to see his assets and their historical data in ISO 95/IEC 62264 compliant model. Enterprise, site, area, production line, work cell, equipment, PLC, tech. And this has to be fast and error-free. The previously mentioned approach with Grafana is neither fast nor error-proof. The technician can very easily crash the database by performing a long-running SQL command without ever realizing that he has just selected 15 GB of data. This crash becomes apparent when the command overloads the database and which then cannot keep up anymore with storing new data, which thereby risks complete or partial system failure depending on the maturity of the implementation. A historian helps the user out here right now. It stores the data and allows the OT engineer to query the data using their language and the models they know, without needing to worry about crashing or overloading the database. And they can do it using drag and drop UIs. The OT engineer can now see his available data points, including metadata, which includes data quality, data types, etc. They can now see it, work with the data, apply averages, perform combined queries, build continuous aggregates, etc., etc. So now let's play devil's advocate. What could be arguments against this? We can think of at least 3 arguments that might contradict the statement traditional IT databases keep OT staff from working with the data. The first argument, hey, let's just ask the technician what kind of data he wants to see and what analysis he wants to do, and then we just pre-build it for him. What's the problem here? A machine usually has a few hundred variables, also called tags, and it would be a waste of time to build all possible views. It's better to give the engineer a tool to do his own analysis. Another argument could be Grafana is bad, you have to use Microsoft Power BI, PTC ThingWorks, etc. But this approach does not solve the fundamental problem that the technician has when interacting with the database. The technician still needs to understand a normalized database, perform joins, and optimize his queries. A third argument might be, but what about InfluxDB? Yes, InfluxDB is indeed an IT database that is well suited for use by OT technicians. It has an excellent visualization that fits exactly the workflow of an OT engineer when he wants to see some data. In addition, the data structure provided by InfluxDB makes an ISA 95 compliant model quite easy. Both points ease the initial friction that an OT engineer might have when working with an IT database. We tested the workflow that I just described with our COO Alex and one of our engineers Anton, and both of them were quickly able to explore their tags. However, as soon as it came to more complicated queries, such as performing a calculation for two tags, they were immediately lost. And almost a year after our first article on InfluxDB, when we take another look, we still come to the same conclusion. Reliability, scalability, and the ability to store relational data are more important than a fancy UI, especially in the field where data storage is often required from a legal perspective. So, we need something else here. What about historians then? Traditional historians discourage IT people from working with the data. So why are we even having these discussions if historians are clearly better than IT databases? Because they are not. Even though OT engineers can work with them, some love them, some hate them, they are quite difficult for IT people to use and understand. Let's take a look at the typical workflow of an IT person working with an historian. Background: you are a data engineer in a larger company with multiple offices. Your job is to fill the black hole of production across the supply chain and apply maybe a couple of machine learning algorithms. You've done a lot of work with cloud providers like Azure, AWS, and you have already been involved in some big data projects with Apache Spark or Kafka. What you have done so far: you've gotten Excel sheets and CSV exports from each of the factory's OT departments and figured out that, in theory, all the data is available. Machine learning algorithms also work a proof of concept scenarios. Now, what is your problem? Now your task is to implement stream processing algorithms and integrate them with the rest of your company's IT, which relies heavily on Azure. However, there is no access to the database except for some strange APIs and connectors, of which the REST API seems to be the best way. So, what would be the intuitive and suboptimal solution? To extract data from the historian. So you then decide to write a service that continuously queries the REST API and feeds the data into your organization's data processing pipeline, where it is processed and then stored in a repository like S3 Glacier. However, you miss out on the real-time data and end up with duplicated data. Once the data is in the historian, and then it is now also in the cloud. So, for the data engineer, the data is lost as soon as it flows into a traditional historian. What could be an alternative solution? Unified namespace. There is another way. While suboptimal, it is doable. And that is rebuilding the entire infrastructure and setting up a central message broker between the PLCs and the historian. This concept is also known as unified namespace, which can be seen as an extended event-driven architecture. This would allow the data engineer to access real-time data and feed it into his organization's data processing pipeline, while the data could also go into the historian to be used by an OT engineer. However, data would still be duplicated between cloud and historian. Let's play again devil's advocate. But there are modern historians out there. They have good integrations with outside systems. This could be a fair point against this argumentation. This is also a very fair point. We've looked at a couple of them. First, there is Ignition. Ignition is marketed as an including historian functionality. However, a look at the documentation reveals that it requires an additional SQL database in the backend. Options include TimescaleDB. So, Ignition combines best practice IT databases with the ease of use for an OT engineer. This could be a good choice for companies willing to use a commercial platform as their central infrastructure. Then there is Canary. Canary says that it is a NoSQL data historian developed in 1985 with over 19,000 installations worldwide. According to the website, it provides support for MQTT, which greatly facilitates integration with a unified namespace and event-driven architecture. However, there is very little freely available documentation on the IT side, which significantly reduces acceptance by IT engineers. We could not find any information on asset compliance, cap theorem, or general consistency by searching the website using Google or their internal search function. We additionally found that it requires Windows and the Windows registry, which might make integration with a modern Linux or cloud-based architecture quite difficult. See also later. Canary's main argument against IT time series databases like InfluxDB and TimescaleDB is that they are VC-backed, which might result in loss of support, product quality, and user satisfaction. In our opinion, this argument is pretty weak, as there are a lot of successful venture capital-backed companies out there. For example, the companies behind Docker, Terraform, or Elasticsearch. What we really liked about Canary is the publicly available pricing that they have, and that they are much cheaper than OSIsoft PI. Let's get to our next point. Typical historians are incompatible with a modern cloud-based landscape. The data engineer is not the only IT person who works with a historian. There are also the system administrators or DevOps people who make sure that the historian stays up and running. And for them, it is just a weird black box running on a virtual machines. Historians have a fundamentally different approach to the topics of reliability, scalability, and maintainability than modern IT systems. By the way, I took the following definitions from one of my favorite books, Designing Data-Intensive Applications by Martin Kleppmann. I can really recommend this book if you want to go into the architectures behind large organizations. Going back to the topic. So, reliability is defined as the ability of a system to continue to work correctly, even when hardware and software faults and human errors occur. Scalability is defined as the ability of a system to deal with increased load. The biggest point here is that there's not much publicly available information on Canary or OSIsoft PI on how these topics are handled exactly. The lack of information makes decision making much more difficult, which in particular complicates internal company discussions between IT and OT. Both OSIsoft PI and Canary mention the topic of replication, but do not explain, for example, as with Canary, how it is ensured here that no inconsistencies occur between the instances. Consequently, all the major IT databases explain in minute detail how they handle these issues. Here you can find in the description links to TimescaleDB, how it handles scalability, replication and partitioning, and reliability, asset compliance, etc., or Elasticsearch or SQLite. SQLite they are even saying that they're not scalable, and they clearly state where they're really good at. This type of information is lacking for historians. The third big point on the fundamental different approaches is the topic of maintainability. Maintainability is defined as the ability of a system to be productively used, which means adapted, changed, expanded, etc., by multiple people over the lifetime of the system. In this article, we will focus on only two operability issues as examples. First, there are no monitoring logging features like health checks or metric endpoints either, so the historian cannot be maintained by the enterprise operations team using their tools like Prometheus or PagerDuty. They have to rely on calls from OT engineers when something is not working. This has a direct negative impact on the time to resolution. Second, historians are usually deployed manually on premises on a single Windows virtual machine. This was also the common approach for a long time before Docker and Kubernetes came around 2014. But today, more and more workloads are automatically deployed and provisioned in the cloud as containerized applications. Advantages are better scalability or the cost of an easier setup. See also our article on monolithic versus Microsoft architecture. A single Windows virtual machine feels like an outsider in this type of architecture. Historians have also recognized this, and for example, Canary is currently developing a containerized Linux version as well. In summary, deploying and running a traditional historian as they are today will likely cause friction with the company's IT department trying to modernize their IT landscape. So, how does the United Manufacturing Hub handle this situation? The ideal solution would be a system that fulfills the requirements of the OT engineer but is still maintainable by IT. For a system to be maintainable by IT, it needs to be built upon IT best practices like, for example, well-established and ACID-compliant databases. It can be open source. It's not a requirement, but it is surely a huge important factor. And to be maintainable by IT, it needs a good integration into other IT systems like monitoring or logging. For a system to be usable by the OT engineer, it needs to speak the same language, ISO 95, etc. And it must have feature parity like easy querying, alerting, and exploring the data. Right now, the United Manufacturing Hub in combination with TimescaleDB has theoretically all required features from IT and OT. It has a reliable and scalable and maintainable time series storage using TimescaleDB. It has connectors to various data sources on the shop floor using Node-RED. It spawns up a unified namespace for real-time data access, including MQTT and Apache Kafka. And it has various stream processing logics and alerting capabilities using Node-RED and Benthos. The last one is still in development. But what the Unite Manufacturing Hub lacks right now is a user-friendly story for the OT engineer. And this is exactly what we've been working on the last couple of weeks. We are currently adjusting the data model to be ISO 95 compliant. We are significantly reworking the UI. We are adding time series functions like gap filling, downsampling, minimum, maximum, average, etc. And we are integrating it with Grafana alerting. This would result in the United Manufacturing Hub being an open source data historian with a strong support for the IT world. If you're interested in a sneak preview, please join our Discord. You can find that in the description. So, to summarize, we're getting to the end here. Traditional IT databases discourage OT engineers, and traditional OT historians discourage IT engineers. There are several approaches to mitigate this problem. Ignition, which provides an OT user interface on top of an IT database, and Clarify, a software as a service offering for storing and visualizing your time series data. Our approach, and as of now the only open source approach that we know of, we are currently extending the United Manufacturing Hub so that it can be used by an OT engineer and maintained by an IT engineer. We accomplished this by using robust IT best practices at the core with an OT-friendly user interface. We hope that this will help us in bridging the gap between IT and OT and continuing to roll out the United Manufacturing Hub globally. So, thank you also for the people who gave valuable feedback for this article. There is Rick Bolotta, the former co-founder and CTO of ThingWorks. There is Mark Jekle, the technical head of IoT at Meibon-Wolf. There is Carl Gould, I hope I pronounced this correct, the co-creator of Ignition. And then there's James Sewell, the principal developer advocate at TimescaleDB. Thank you for listening.